Okay, in IM2 today we're going to talk about two-way tables and probability. Okay, this is your first exploration in your journal. This is on page 166, and this is exploration 1. So a two-way table displays the same information as a Venn diagram. In a two-way table, one category is represented by rows. Rows go side to side, and the other piece of information is represented by columns. Okay? So the Venn diagram shows the results of a survey in which 80 students were asked whether they play a musical instrument and whether they speak a foreign language. Use the Venn diagram to complete the two-way table. So the first thing you want to look at is, what information do I need? So the first thing I notice is that there are 80 students. Okay? Right here is where that information should go. And then those students that play an instrument and speak a foreign language would be the ones in this section. So you just keep using all the information to total this out until you've completed the whole thing. Okay? So now we're going to look at the questions. So how many students play an instrument? I go over here. Now it might be easier to go here, but you'd have to add the information. So the total that play an instrument is right there. So if you want to push pause and complete this exploration on your own, go ahead and do that. And I'm going to go ahead and put the answers up. How many students speak a foreign language? How many students do both? How many don't do either? And how many students play an instrument but do not speak a foreign language? Okay, so we're going to use this same information for the exploration on exploration 2, which is making probabilities out of this information. So remember, to find a probability, it's the number of outcomes over the total possibilities. In this case, there are 80 total possibilities. So if you're looking at the probability of playing an instrument, we're going to look at 41 over 80. And that gives us the probability for A. So again, I suggest that you push pause and see if you can do these on your own, and then I will put the answers up. So speaks a foreign language. That, remember, we're going to go to the total here. Now what I want you to notice is when you get this answer, it's different than mine because you probably got 46 out of 80, but remember, you always want to reduce your probabilities. Okay, so C would be does both, so that's going to be this answer. And again, that would be 16 out of 80, which reduces to 1 over 5. Okay, so the next one, does not play an instrument or speak a foreign language. That's 99 over 80, and that does not reduce. And then plays an instrument but does not speak a foreign language. That would be 25 over 80, which would also reduce. Okay, so make sure you're remembering all those little details. Okay, all right. So making a two-way table is, first it's going to tell you that a two-way table is a frequency table that displays data collected from one source that belongs to two different categories. One category is represented by rows and the other by columns. So this is kind of going over what we already said. So each entry is a joint frequency. It's a joint frequency because it comes from two different pieces of information. Okay? Now, if we put the totals on here, then these are called the marginal frequencies. The totals, the sums of the rows and the columns, are called the marginal frequencies. Okay, so that's really important. Okay, so we've already discussed what a frequency is, and that's where we just make tally marks or put numbers to tell how much we got for each piece of information. Each one of these is a joint frequency. Remember, we called these joint frequencies because they are the result of two pieces of information. Okay, they're coming from two tallies. Okay, so when we calculate the percentage to the total, that's where we get these two. So a joint relative frequency is when you take one of those individual joint frequencies and you tally it to the total number. So see, here is the total of people surveyed, and this is the number of this. So we would calculate this specific joint frequency over the total. That is called a joint relative frequency. When you go down to the totals, the margins, remember those margin ones, when we get those, it's 35 over the total. That's a marginal frequency. So this is the joint relative frequency. And this is the marginal relative frequency. So you can see the difference. And I like to think of the relative as one of the whole. So this is the joint relative frequency. So it's the joint frequency, but we're finding the percentage of the whole. And this is the marginal frequency, is this number here, but now when we say relative in it, we're finding the percentage of the whole. So that's how you had to understand the difference. This was a joint frequency. When we put it over the total, then it becomes a joint relative frequency. This is a marginal frequency, and when we put it over the whole, it becomes a marginal relative frequency. Now, the conditional relative frequency is specific, and they don't show a picture of it here, but I think of the mnemonic for it as a straight hair. If your column was made to equal 100%, okay, then your conditional relative frequency would be out of this total. This would be your total, not the total of the box. So it's not this total, it's the total of the column. Okay, so each one of these would be 100%. Now, sometimes it will be out of the row. So for that case, and you don't ever have them at the same time, but this would be 100%. Okay, and so this would be the total for your conditional frequency, relative frequency. So be careful with that, okay? So we'll do some examples to explain it a little bit better. Okay, so we're going to talk in this one about how to create the marginal frequency table, okay? So finding the joint and marginal relative frequencies. So the first thing we could do is this one would be 42 over 220. And we would reduce that and find the percentage. Okay, so here is what it would look like. To find the joint relative frequencies, divide each frequency by the total number of students in the survey. Then find the sum of each row and each column to find the marginal relative frequencies. Notice that this should still add up to 1, and this should still add up to 1. Okay, and then this gives you some information about each one. Okay, so push pause if you want to get some more information out of there, but that's what it should look like. Okay, in a survey, 214 ninth graders played video games every day of the week, and 22 ninth graders did not play video games every day of the week. Of those that played every day of the week, 36 had trouble sleeping at night. Of those that did not play every day of the week, 7 had trouble sleeping at night. Make a two-way table that shows the joint and relative and marginal relative frequencies. Now, this has just a couple numbers, and it's giving the relative frequencies already. So it's got 2 of the joint relative frequencies given. This is our total, which should always be 1 unless it's a conditional chart. And so we got to use the information that they've been giving. So the first thing I'm going to do is I'm going to look at the survey was of, it doesn't tell the total. So we don't know what the total, this is 100%, okay? So we don't know what the total is, but we know that 214 played video games every day. So we're going to put 214 here. And 22 did not play video games every day. So that gives us our total, okay? So our total is 236. Now we can start looking at the chart a little bit more clearly. Of those that played every day of the week, 36 had trouble sleeping at night. So we're going to go 36 here. And of those that did not play, 7 had trouble sleeping. And that one goes right here. So now you can check the math. This should be 7 over 236, and we calculate that out, and this is correct. So we also can look at this, 36 plus 7, we can add that up, and 36 plus 7 is 43, and we can calculate 43 over 236, and we can get this total. Okay? And then we can go from there, and we could subtract the 0.03 to get this number. Or we could calculate this as 36 over 236. Either way, you can fill out the chart with the information that you have plus the givens that I gave you. Okay? You didn't need my givens, I just did that to be nice. But if you push pause and want to finish, and then you can fill this out, here are the correct answers. Okay? So there you go. All righty. Okay, so now we're going to look at Okay, so this is how they showed you how to find conditional relative frequencies in the book. And I've done it a little bit differently in the past, so I'm going to go over both ways. So what they did was they calculated all of these joint relative frequencies. So they did 42 over 220, and that equaled 0.19. And then they calculated 106 over 220. This is a marginal relative frequency, and that was 0.482. Then to find the conditional relative frequency, they did the junior attending, which was the one we discovered up there, over the total juniors, and they got this one. Now, how I learned to do it was I just did 42 over 106, and that equals 0.396. So that's how I would have done it. I think it's a little bit faster if you're given this. If you're not given the joint relative frequencies for this whole thing, then I would just go ahead and do based on the row. So you would take the number and the total would be your row. So that's another way to do it. So look at the two different ways, see what you're most comfortable with. It really depends on what information they're giving you. If they were giving me just the frequencies, the relative frequencies, and the marginal frequencies, then I would go ahead and do the 42 over 106 when they tell me they're doing the row. If they were asking for the column, given who is attending, then I would say 42 over 119. But if they go ahead and give you all of these answers, okay, 0.35, and this is 0.518, then you could go ahead and quickly figure these out this way. So again, it's the same information found in a different way. All right. Okay, so finding conditional probabilities. So they gave you all of the relative frequencies here. So they gave you the joint relative frequencies. Okay, these are joint relative frequencies. They are not giving you the marginal frequencies or the marginal relative frequencies. Okay. So we're going to look at the answer. So it says, a satellite TV provider surveys customers in 3 cities. The survey asks whether they would recommend TV provider to a friend. The results given as joint relative frequencies are shown in the two-way table. So what is the probability that a randomly selected customer who is located in Glendale, so they're saying they're in Glendale, will recommend the provider? So first thing you have to say is they're going to say yes, and they are from Glendale, and they say yes based on they are in Glendale. So you have to add these together, find the total, the marginal, which would be 0.35, that's what I would look at, 0.34. And so you would go yes over 0.34, and that gives you this. Okay? The second one, what is the probability that a randomly selected customer who will not recommend the, so now you're looking at the, this is based on the saying no, not recommending. So that's your basis, so that's your denominator, and is in Long Beach. So a no from Long Beach over all of the no's. So that's how you would do that one. And again, you could just add them up, 0.4, 0.5, 0.3 would be 0.12 is your base, and it would be 0.04 over that, and you would get that total. Okay, so that one is this is a conditional relative frequency. These are all conditional, but you can find them quickly by doing the totals. Okay, determine whether recommending the provider to a friend. So recommending is yes. So recommending is yes, and living in Long Beach are independent. So this is where we're going to look at living in Long Beach. So you want to do both, and you're going to see if they have the same probability. Okay, so look at this one carefully and research it. So use the formula PB equals P given A and compare the probability of Long Beach and P Long Beach yes. So the probability of Long Beach is the total here, okay, and that's 0.36. And then the probability of Long Beach and yes, so yes and Long Beach over yes, and we add those up, and we get that they are the same, so therefore the two events are independent. So the fact that they live in Long Beach is independent from the fact that they are Long Beach and say yes. So there you go. All right. Another example in the book that I thought was really good is this one, comparing conditional probabilities. And a jogger wants to burn a certain number of calories during his workout. He maps out 3 possible jogging routes. Before each workout, he randomly selects a route and then determines the number of calories he burns and whether he reaches his goal. This table over here shows his findings. So he needs to know which route he should use. So what he's going to do is he's going to use the findings to make a two-way table that shows the joint and marginal relative frequencies. So this is what he does. He takes each one of these, there were 50 outcomes, and he calculates the joint and marginal relative frequencies. Then he found the conditional probabilities by dividing each joint relative frequency in the column by the marginal relative frequency in its corresponding row. So then he did calculations and found this out for each one, and he found out that the probability is best to reach his goal for route B. Okay, so that's how you do that kind of a problem. All right, so the last thing we're going to do is number 5, and on page 170 in your journal. So for financial reasons, a school district is debating about eliminating a computer programming class at the high school. The district surveyed the parents, students, and teachers. The results, given as joint relative frequencies, are shown in the two-way table. What is the probability that a randomly selected parent, okay, so you're going to look at the parents, voted to eliminate the class? So the first thing you want is the total number of parents. So add these two numbers together, and then you're going to put voted to eliminate. The answer would be yes. So there's your answer. So 91% of the parents said get rid of it. Okay? What is the probability that a randomly selected student did not want to eliminate the class? So you're going to add the two rows, add the two numbers, and get the total, and divide it by did not want, which would be no. So 0.15 over 0.23, 65% of the students did not want to eliminate the class. And then it says determine whether voting to eliminate the class and being a teacher are independent events. So that's kind of silly because they are definitely independent, because just being a teacher would not force you to have voting to eliminate, because very few of the teachers did. So the events are independent, the probabilities are not the same, because the probability of being a teacher was not the same. Okay, so there you go.